This video is an example calculation for photon energy. So you have a worksheet that kind of looks like this. You're given the energy, and then you have a blank for frequency, a blank for lambda, and a blank for your nanometers. So the first thing you're going to want to do, we know also the values for H and C because they are constants. We were given E. The only equations we know for this unit are E equals H times V and C equals lambda times V. If we know our E already, and we know H because it's a constant, our only X is V for this equation. So it makes sense to use this equation first. So we're going to go ahead and write E equals H times V. And then we're going to plug in the number 6.92 times 10 to the negative 20th joules equals H, which you'll see in your last video is a constant. This will be on your formula sheet, 6.63 times 10 to the negative 34th joules times seconds times our frequency. The way that we can get our V to be alone, we're going to divide both sides by that H value. You may notice that while I write these numbers in scientific notation, I am specifically putting parentheses around each number. The reason why I'm doing this is because the calculator is going to follow a certain set of order of operations. And if you do not put a parenthesis in there, it's going to multiply by the wrong number instead of dividing. So exactly how I have it written right here is what you need to put in your calculator. So take a look to the right of the screen. I'm going to put parentheses 6.92 times 10 to the, sorry, I forgot how to use this calculator, negative 20th, and then I'm going to close my parenthesis. Then I'm going to click the divided by sign, and I'm going to open my parenthesis again, and I'm going to say 6.63 times 10 to the negative 34th, and I'm going to close my parenthesis, and I'm going to click equals, and I get this number. V equals 1.04 times 10 to the 14th hertz. Okay, so now that I have that frequency, I know C because it is a constant, and if I'm missing lambda, all I need to do is solve for lambda. Oops. So I'm going to go ahead, I'm going to say C equals lambda times V. And I know from my formula sheet that C is 3 times 10 to the 8th meters per second. I don't know lambda yet, so that's my X here essentially. And I can plug in my frequency for V, which is 1.04 times 10 to the 14th hertz. Now that I have everything plugged in, and I only have one unknown variable, I can solve for lambda. So I'm going to divide both sides by my frequency, and this becomes 1.04 times 10 to the 14th hertz. 1.04 times 10 to the 14th hertz. These guys cancel out, and now in my calculator, I need to type exactly how I have this written. Whenever I'm using scientific notation, I need to be using parentheses. So I'm going to say parentheses 3 times 10 to the 8th, close my parentheses, divided by open parentheses 1.04 times 10 to the 14th. And then I'm going to close my parentheses, and I'm going to click equals. And I get the number 2.88 times 10 to the negative 6th. Okay? Now, the last box on your paper asks you to move it to nanometers. So the conversion we do for nanometers, we're going to do whatever we were given in meters divided by 1 times 10 to the negative 9th meters. And that will get us our conversion to nanometers. So I'm going to do whatever I had for my lambda before. I'm going to say 2.88 times 10 to the negative 6th meters divided by 1 times 10 to the negative 9th. Again, using parentheses. And I get the number lambda equals 2,880 nanometers. Okay, so the math itself really isn't that bad. It's just people get freaked out about the calculator and about these yucky numbers. But if you know how to solve for x, that's all this is. Just be careful about your calculator and the parentheses.